Hey, welcome back to the second part in the Kaggle series. It has been a very long time since I touched this because of private reasons, but I'm back to it. And I'm actually quite excited to get started a little bit more. So the only thing I did before starting the recording the video is to check if we can actually submit Kaggle results from our notebook instead of going through the homepage. And if you Google for Kaggle API, you can find the official documentation on how to configure this, and then you can just set it up. I mean, just follow the instructions. It was pretty straightforward. And then I tried it, so I can now call this Kaggle client and say I want to submit to the competition Titanic. I want to use the submission CSV, which is in the same folder. You can select the message. And then you can also display the competition. You see here's my Jupyter submission. And now let's see if we can improve on this a little bit. So what we did last time was actually we just looked a little bit at the data set and we took all the numerical columns and just trained the model on it as far as I remember. Here we looked at various survival rates of passenger classes, and you can see passenger class 1 was 62% survival rate, while passenger class 3 was only 24. So this is probably a pretty strong feature. We can also take a look at the coefficients, and just from the coefficients we see that the higher your passenger class, the lower your survival rate. And this is what we see here. So everything looks fine. We did some estimation on accuracy and receiver operating curve. I think I will need this for later. One thing we can do next is we can actually start bringing categoricals into the mix. So let me just see, does this still work? Let me just load all the data. I think I haven't. If I check embarked, seems to be probably not sure what these codes mean, but embarked would mean that maybe somebody stayed home, and then I would expect that these people have a survival rate of 100%, but not really. So we cannot use non-numerical values, and probably, or maybe we also want to encode the passenger class differently. There might not be a linear relationship between them. Maybe we can look into this a little bit. Let me just see. Okay, in terms of pre-processing, where do we specify the features? This is the features that we use. And here we just trained it. Oh, good. I guess I should execute all of these. Oh, let me just execute everything again. sklearn cross-validation. Did this change somehow? Did they change this? Do I still need this? Is the question. Yeah, we didn't even train on all the data. Okay, there's a lot of room up. So let's first start with more additional features before we fix the rest. And then let me just remember. Okay, so for example, if we want to use this field embarked in our logistic regression, we somehow have to encode it, and I think Pandas has something for us. It's or is it just called dump? Embarked. Can we select this? Get values. I forgot what the function name is. Get thought it was dummies. Maybe it was pd get dummies data frame embarked. Oh yeah. So if you want to one-hot encode categorical variable, pandas can do this for you with get dummies, and then you see you get these as a column values, and then for each sample you have the one-hot encoded vector, which is probably something we're gonna do. We somehow need to join this to our initial data frame. I think pandas has many ways of concatenating to data frames. Let's just see this one. Does this work? Maybe not. This one used the wrong axis. It stacked them horizontally instead of vertically. Now you can see we joined this to our data frame. This is actually something I want to do, and mutate our initial. This works. Cross decomposition. Okay. Tests. Let me just think. How could this be called? Yeah, should be cross decomposition. No. Yeah, that's what I expect. How do they call this now? Feature extraction, feature selection. No. They must have changed this in the newest version. I could also just look it up. Decomposition, cross decomposition, calibration. Maybe I'm just not seeing it. Model selection here, maybe model output. Let's just and here we are looking for split. Model selection, interesting. Now good, if that's how it should be. Okay, it's not iterable, so they changed this quite a bit. How does this work now? Int dot split x and y. Okay. Index test index, I guess. Well, where's train index test index? So I need my training data. Okay. Makes sense. You see, I've been away a while from the scikit-learn world. We use our data and our labels. I'll explain also. Execute this, execute that. Train index is not also. Okay. This is dumb. I should be a bit. Oh, did we only train this on survive? No, we trained it on everything. Let's see. Okay, shuffle split v, pass n splits, test size, and random state. Shuffle split v, pass n splits. We only need one. Random state 1, and then test size 0.2, something like this. Now we have our splitter. Our x is our df feature columns. Let's define this in a second. and our y is the label column. Okay, then we don't need this anymore for now. We don't need this anymore. Here, this one is going to become our feature columns. And here we're going to add our C. We should give it nicer names, but for now, this is going to do. Feature columns, label column is going to be, that's the label column. Survived. Okay. Survived. Does this work? This worked. Okay. Now make a proper loop for x, frame, y. This is gonna give us for only the indices. Okay. Frame index in split split x and y. We want to stay with logistic regression for now. I know that probably in the end tree-based classifiers are going to win this, but I still think it's interesting to look at this. Let's check. Okay, and then let's import this. Let's put this into our loop here. Oh, this is not what I wanted. Please. X train, Y train, X train, X, and then we replace frame test, and we train and we predict. Predict X test. Okay. Print. Let's make this print statement nicer in a second. Let's see if this runs. Key error. X and Y. One second. Train index. This looks okay. Yeah, this one. Expand is already on the features. Why is this complaining now? Because it's a data frame. So we can do probably. There's no attribute, we don't need to fill anything anymore. So many errors. Okay, contains none or infinity. This is because here we want to do. For now we fill with 0. I think I mentioned in the previous video that this is probably not optimal, but it will work well enough. Okay, cool. This works. So we want to define this one down here. And let's say we want to have 5 splits or something. Let's see how stable is it across this. I would want to specify a solver. I don't want these warnings. Solver. Maybe. No, then let's take this. LBFGS. Okay. Fail to converge. Increase the number of iterations. No. Switch penalty for bronze monster. So how can I do this? Max leader. I don't know. Okay. Okay, cool. And then let's make this print statement a little bit nicer. Precision recall. I think the competition only cares about accuracy, if I'm not mistaken. Rules? No, leaderboard discussion data. Where does it say? Notebooks discussion leaderboard rules. Maybe rules? Unsure. We would need to read a little bit closer which metric is used. I think it is maybe accuracy. So we only mainly care about the first value here. In the end, we want to actually take this logistic regression if we are satisfied with it. So one thing we can immediately check is, for example, if we comment the new features out, does it change? It's maybe hard to see in this. So if this has any impact on our accuracy across our folds, X, and then okay, 67, 67, 68. So this helps a little bit, maybe not so much. We of course train on all data in the end. X train X and 1. 1, 2, 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. Okay, this seems to be all. Okay, I'm just cleaning this up. Then here we need to get our test data. Do we load this somewhere? I have test. Let's do this. Let's do that. Does this just work out of the box? Columns, feature columns, this needs to be. And here we will not have the correct columns, so let's actually, okay. Let's load this at the top, and here where we start building new features, we should actually also build them for test data frame. So maybe maybe we make a list of our, no, let's copy it. Okay, we have the test data frame, we concatenate the test data frame and get dummies of testdf embarked. Testdf is not defined because we didn't execute this. We can just re-execute all of this. It's not defined because it's df test. df test. df test. Okay, cool. Let's just make this whole notebook a bit smoother. Let's just submit this to see if this works. And then you can see our model actually got worse on the test day. So we overfitted somehow on this. Or we have some other issue. I have to think about this a little bit. For now, I still want to do some more cleaning up. So for and feature in zip feature columns and coefficients print feature and so yeah, this is actually in the way. Okay, so and then we should it sorted according to the last one. So now we see that parch, p-arch is the strongest indicator for surviving, and p-class is the strongest indicator for not surviving. We should read up on what SQ and whatnot means. It's probably here. This is where people actually enter the Titanic. Okay. If we can see that if you enter the Titanic in Q, Queenstown, you are more likely to survive than you entered in S, Southampton. Now we could of course check if this is actually because all the rich people live in Queenstown. Okay, let's see. So I want to add all the other columns as well. If you're female, you're much more likely to survive. So I think this will help our model. And I guess if somebody with a statistics degree sees what I'm doing here, you might be cringing, because I think doing a proper analysis of all the variables and then checking if actually there's a linear dependency or something, and would be a much better way of building a logistic regression model. I want to get to that. I first want to make a data frame that I can work with, and then we're going to look at a couple more plots and see if we can actually do something with it. So instead of also just making a one-hot encoded feature, so this is another thing. So here we just got the dummies, and the dummies just took all our 3 classes and made a one-hot encoded vector out of it. We can actually leave one of those classes away and essentially move the weight of this class to the intercept, because if both of the others are 0, we know that we are in the 3rd class. I'm not entirely sure how this is actually, if this is an issue if you have multiple categoricals. So we should also print the intercept for no, right, no. I guess, not 9, 0. So if we remove one of the classes, it will essentially move its way to the intercept, which I'm not sure if they actually, if this is not good if you have multiple classes, because then the intercept is actually modeling maybe some conditional, like if you're on the intercept, then you're in Queenstown and you're male, and your, do we have anything else? Your cabin is something specific. Let's just check this. So instead of this, I want to do df.gender, score gender. No, get dummies. Also not. X. There. So, and here, this one we model as one of the classes only. So this apparently helped us a lot. So now we know, if you look at this, suddenly all the coefficients changed, which is quite normal. Now the combined weight of all of the features is different. One thing that's interesting to me is that now all the points of embarkment get the exact same coefficient, which is slightly weird, I guess. I would have to think about this. Also, suddenly nothing is helping you anymore into the positive direction. So you just have a really good intercept. The intercept, but the intercept was much higher before. Currently the intercept says on average you're going to survive, but depending on your class, you will die. Which is interesting. I want to see, let's just see. So removing those doesn't have a big impact. This was weird because we expected to be, if you're a female, you should be more likely to survive, like we can see here, like 70% of females survive. So as soon as we see this feature, we can be already quite certain that you won't survive. So maybe the combination of being female and being in the worst class is going to help us find the females who didn't survive. But as soon as you enter these points of embarkment, it gets weird. Because now being female makes you worse. So there is maybe a collinearity between those features. Or we can also now try what happens if we leave one of those classes away. But this just completely breaks. So we should check how is this related. The class that you embarked in. This is very interesting. I need to think a little bit about this. This is actually something I would more expect, and I think this model could be quite all right in terms of how it's performing. One last thing we can check before we end this episode is there's probably hundreds of cabins, I guess, and sort values. What's the function? And we want to have the total, and then reverse this. What's the parameter? Not print. I don't remember what the parameter is. I will look it up later. We just look at the bottom. So it seems the data is very sparse in the sense that the cabin with the most people in it was 4, which, okay, yeah, if you think about this, you have cabins, 4 people live there, half of them died. Will this help us with the test set though? So if we include this data into our model, we could, for example, run, oh, in this cabin, everyone survived. So maybe if someone from this cabin is also in the test set, he's more likely to also survive. While if you're in a cabin where everyone died, you're less likely to survive. I'm not sure we should incorporate this because this is very specific and our model is highly likely to overfit on this in our training set. Especially, we would need to check how many of these cabins actually appear in the test set as well. So since the video is already approaching 30 minutes again, and this was maybe a little bit confusing, I think we're gonna end here. Did we include age already? Yeah. Okay, let me just see. Yeah, we do this later. We can play around with fill NA as well. Currently we fill 0, which is maybe not so good for a logistic regression model. We will just submit this model, which now adds is female as a feature, which is pretty strong. And then let's see. Pending. Yeah, this already brought us from 66 to 76, just incorporating whether you're a female or not. In the next episode, I will start some plots, and we're just actually going to look at some features and how they are distributed. And yeah, see you.